In this lesson, we will go more in depth into the ecosystem, specifically how matter is cycled and how it is used in the ecosystem. We've already gone through the pyramids of energy, which explain the hierarchy of energy in an ecosystem, but we will see how energy in material form is circled around in the ecosystem, and how nutrients in the biosphere are transferred from one organism to the other, or from one organism to an abiotic factor. And we call this process the biogeochemical cycle. We will start out by going over the 4 cycles, which will be the water cycle, the carbon cycle, the phosphorus cycle, and the nitrogen cycle. And to go through this, there are 4 factors here. There is the earth, which is the soil here. There is the air, there is the water, and then there is the combination of all 3, which is the biosphere. Starting with the water cycle. The water cycle begins at the evaporation stage, where a large water mass will evaporate because of the heat brought on by the sun, which will later condense, and then it will cause precipitation. And then water from after precipitation has 2 options. Either the water will go off as runoff and then be surface water, which can be used for plant uptake. It goes around everywhere. Or water will go through the infiltration route. It will go through the ground and later on be turned into reservoirs by a process known as percolation. You are not responsible for knowing about either sublimation or deposition. What you are responsible about, though, is knowing that plant transpiration constitutes 10% of total water. Now we'll be going over the carbon cycle. The carbon cycle can be broken into 2 parts. The long-term carbon cycle, between fossil fuels and combustion, and the short-term carbon cycle, which occurs between respiration and photosynthesis. Now in the short-range carbon cycle, there are 2 parts, terrestrial and marine. In the terrestrial part, animals and other organisms will use respiration, which takes in oxygen and releases carbon into the atmosphere. And plants and other photosynthesizing organisms will take in that carbon oxide and then release oxygen. Now, the water is a little bit more complicated. Carbon cycle will diffuse into water, which will then be used by plants and algae to photosynthesize, or it will react with the water itself and form bicarbonate, which are used by some animals as homes or shells, and they do build up in the sediment at the bottom of the ocean. Another source of carbon dioxide in the ocean is marine animals such as fish going through the process of respiration. They will also release carbon dioxide into the water. Now, an important thing to consider is bicarbonates, while they may hold carbon dioxide for a short period of time or a long period of time, they also are capable of being lifted back up and diffusing back into the atmosphere. So bicarbonates can hold carbon dioxide as a compound, and they will be able to also release it as a compound later on. Now, the long-term cycle consists of dead animals which get buried and over millennia are turned into fossil fuels. Examples of fossil fuels are like oil, gas, coal, and there are more. And then later on, humans came around and they dug up these fossil fuels and they are used in combustion. They can be used in industry, and all of these will release CO2 back into the atmosphere, which was trapped by the fossil fuels. Here's another picture, a much simpler picture about the carbon cycle. Though this one will not include the long-term one, you can look at it as follows. You have animals, which contribute respiration. You have combustion, which will contribute carbon. And then you have photosynthesis, which is capable of reducing carbon and releasing oxygen, but you also have plants respirating. An important thing to note is that plants will take in much more carbon than they will give out. So they are still outputting a net positive, even if they do respirate themselves. And decaying organisms, I'm not talking about the ones being turned to fossil fuels, I'm talking about organisms just being decomposed, will also release carbon. Now onto the nitrogen cycle. The nitrogen cycle is probably the most complex one because there are so many things going in and out of the cycle, so you'll need to pay attention. We have multiple examples of it. The nitrogen cycle is related to only one element, and it's nitrogen, as opposed to carbon and oxygen cycle. And it consists of as follows: atmospheric nitrogen, which is the nitrogen in the air, N2, and all forms of nitrogen within the soil. Nitrogen that can either be used or that is trapped in compounds which will later be usable for plants. As we can see here, animals are contributing to the nitrogen cycle because their waste, mainly their urine, has ammonia in it, which can later be turned by bacteria into nitrates, which are used within the soil by plants. Though another source of nitrogen would be the atmosphere. A great percentage of our air is made out of nitrogen, and then this nitrogen can be turned by bacteria into usable forms at the nodules of plant roots. Now, a third example would be the underwater nitrogen cycle, which is fish both urinating and fish excreting waste. And that nitrogen is often sent down to the bottom of the ocean where it forms layers of sediment which are unusable by all means. Now here's another picture, and a much more simplified picture. In this picture, as you can see, let's start from the animals because it's a simple starting point. An animal's waste could later on be used by decomposers to be turned into nitrogen, or an animal's dead bodies or its remain will be also turned into nitrogen by decomposers. But a factor which you must account for is denitrifying bacteria, which is not mentioned in the previous slide. It is bacteria capable of taking usable nitrogen, such as nitrates, and releasing it to the atmosphere. And it is the opposite of nitrifying bacteria. Now, plants cannot use the nitrogen into the atmosphere, as previously mentioned. So the plants either need nitrates or pure nitrogen delivered to them by the bacteria at their roots. Here are important process names you should know. You should know what assimilation is, which is just nitrates being formed at the plant's root. You must know what ammonification is, which is the breakdown of animals' urine into ammonia and then turning it into nitrogen, but that occurs by another kind of bacteria, which is also present in some plant roots, but that's mostly in desert. Now, ammonium, NH4 plus, is not usable by plants, so plants will need to go through one more step of nitrifying bacteria, which will turn it into nitrite, and then another form of nitrifying bacteria, completely different from the original, will turn it into nitrate. We could also take a third example, because as I said, this is a really difficult concept. We can see here that similar to the other model, there's the animal, the plant, and multiple different layers of bacteria. So there is the plant directly taking nitrogen from the atmosphere, or nitrogen fixing soil bacteria turning the nitrogen into the atmosphere into ammonia, and then other bacteria turning it into nitrite, which is turned into nitrate. Let's keep in mind here the plants want nitrate. So if they tell you in the exam ammonium being turned into nitrogen, which can directly be used by the plant, you cannot say it's directly used by the plant. The plant are unable to use the nitrites. It needs to go through another step of nitrifying bacteria to be used by nitrates. But if they see going through bacteria in general to be used by the plants, you can directly say, yes, we are changing the ammonium to a usable form of nitrogen, which is nitrates. Now, the final process is assimilation, which is the plants using the nitrates in the soil. And there is nitrification, which is turning ammonium into nitrite. So the difference between nitrification and assimilation is nitrification is from ammonium to nitrite. Assimilation is from nitrate from nitrate directly to the plant, and nitrifying, which is a general term because it can be used for nitrification, is turning nitrites to usable nitrate. Another key factor to keep in mind is that while decomposers do break down dead bodies, they do not directly break down dead bodies to a usable form of nitrogen. They break it down to ammonium, which later goes through a two-step process. Finally, we have the phosphorus cycle, which is a very simple cycle. It can be broken into two cycles, much like carbon and oxygen, long-term and short-term cycle. In the short-term cycle, we have the cycle between plants, animals, and decomposers, which occurs in the soil. And in the long-term cycle, we have the cycle that occurs between sediment and weathering, which will occur if there is a large water reservoir. In the short-term cycles, we have plants which need phosphorus and also release phosphorus when they are eaten by animals, which are later decomposed. So a plant will take phosphorus from the soil, so it may make its food. And then once the plant is either eaten by an animal or it dies, it will start releasing that phosphorus. So it can either be directly released by a decomposer, as shown here, or it will be eaten by an animal which will later be decomposed, which will also release it to the soil. And then that can be used to the plant, and it goes that way. Or we could look at the long-term cycle, where the phosphate in the soil, rather than being used by plants, will leach into a water solution, and then over time chemical precipitation will occur, which is similar to normal precipitation such as rain, but rather than having rain happen, you're having phosphate fall down to the ground in a solution. And as the phosphate falls down, it sediments, causing rocks. Then by a process known as geological uplifting, it is lifted out of that solution and onto the mainland. And then over time, rain, through the form of runoff, will break down these rocks, which will either go down to the soil and be used by plants, or will go down to the soil and go back to the water, and the cycle continues. Obviously, in both carbon and phosphor, the long-term cycle takes much more time than the short-term cycle, hence it's named the long-term cycle. And that is all for the water and oxygen, nitrogen, phosphorus, and carbon and oxygen cycle.
That'll be it for lesson 2.3, Cycles of Matter. If you have any questions or want to ask anything at all, you can ask it down below in the comments or in the server. If you want more tutorials like these, you can find them on the channel, and yeah, enjoy them.